Hey everyone, welcome back to Andrew and Amandeep, the show where I sent for Mr. Buttar. Um, recently, some of you may have heard, I got a selfie with Mr. Buttar, so that's cool. We're one step closer. Anyways, today we're going to be taking a look at what d over dx means, right? So this is a bit of a confusing idea, so we gotta unpack it a bit. So here we are. So we've got d over dx, and this is an operator. Okay, we need to understand this. This is an operator. This is an operator in the same way that sine, stuff like log is an operator. If I just ask you sine, what is sine? Well, there's no answer. Sine isn't something, sine doesn't have a value. Sine operates on a value, so if I give it pi, okay, well cool, now it can give me a value. Same thing with log. This can give me a value, but log by itself doesn't give me a value. This is the same idea with a derivative. D over dx just means the derivative with respect to x. The with respect to part comes from this here. This is what it's with respect to, and we'll get into that later. So if we have just d over dx, we're not really taking the derivative of anything, we're just saying derivative. So that is why we consider it an operator. Now, if we were to have a function y, right, let's say y is something simple, x squared, then we can say, okay, let's take the derivative of y, right? So let's put it here. We'll put it on top. This is what we're taking the derivative of now. We're taking the derivative of y with respect to x. This with respect to is a really important concept that we'll see later more graphically. For now, all you need to know is that we're differentiating this expression here. So some of you may know this is a simple differentiation. We just use not the product rule, the power rule. We can bring this exponent down as a coefficient and subtract 1 from it, so we just get 2x. So here we are. So this is how you would write derivatives with d over dx. d over dx is known as Leibniz notation. So let's write that, Leibniz notation. Here we are, okay. And this is contrary to what we have learned before. We've been using prime notation, right? F prime of x. This is called prime notation. Now both of these have strengths and weaknesses, but generally we'll see a lot more use out of Leibniz notation, so it's helpful to know what it means. Join us in the next video where we'll take a look at a graphical idea of what with respect to really means. Anyway, thanks for watching, and remember to subscribe. 50 subscribers, I'll ask Buttar to the dance. See ya.